All right, today we're talking about something huge. We're looking up, way up, to see how a whole new generation of satellites is building networks in the sky. And maybe, just maybe, solving one of our oldest connectivity problems for good.
You know the feeling, right? You're driving through some hills, maybe you're out on a boat, or just in a weird part of town, and poof, your signal is gone. No bars. We've all been there. And it makes you wonder, in this super connected world, how are there still so many dead zones?
Well, the answer is actually right under our feet. Almost all of our digital life, our calls, our streams, everything, runs on what are called terrestrial networks. And that's just a fancy way of saying stuff on the ground. Think about all the fiber optic cables, the phone lines, and, of course, all those cell towers we see everywhere. That's the backbone.
And here's the problem. That backbone can only stretch so far. I mean, it's just not practical or even possible to run a fiber cable to the middle of the ocean or put a cell tower on every single mountain peak. And because of that, huge parts of our planet are left completely in the dark, digitally speaking. So if building out more stuff on the ground isn't the answer, the only other way to go is up. And that's where things get really interesting with something called non-terrestrial networks. Non-terrestrial networks, or NTNs for short, are exactly what they sound like. They're wireless systems that don't live on the ground. Instead, they use satellites whizzing through space or even high-altitude drones to beam connectivity straight down to us. This totally bypasses the need to build physical stuff everywhere.
But here's the thing, not all satellites are the same. A lot of it depends on their orbit. For a long time, we use these geosatellites that are way, way out there, like 36,000 kilometers away. And that massive distance creates a delay, what we call latency. But the real game changer? That's LEO, or low Earth orbit. These satellites are so much closer, which cuts that signal travel time way, way down. And trust me, that low latency is everything. It's the difference between a video call that's constantly freezing and one that's perfectly smooth. This LEO revolution is what's making high-speed internet from space not just some sci-fi dream, but a real game-changing technology that's here today.
So, once our data zips up to one of these satellites, what happens then? How do they actually handle it all? Well, to get that, we need to understand how a satellite actually thinks. Okay, so every satellite has something called a payload. You can pretty much think of it as the satellite's brain. It's all the high-tech gear that does the actual work. In this case, grabbing our signals, doing something with them, and sending them back down.
And there are basically two ways this brain can work. The first is what's called a transparent payload. It's pretty much just a simple mirror in space. It catches a signal and just bounces it right back down, unchanged. All the real thinking happens on the ground. But the second, much more advanced way is the regenerative payload. This is a smart repeater. This thing actually has a 5G base station on board. It can process the signal, clean it up, and intelligently route it while it's still in space. It makes the whole network way more powerful and flexible.
So we've got these zippy LEO satellites with super smart payloads. That's cool tech, but what does it actually mean for you and the phone in your pocket? This is where it all comes together. It means we are right on the cusp of direct-to-device connectivity. This is the holy grail. We're talking about the ability for a regular, off-the-shelf smartphone, the one you have right now, to connect directly to a satellite. No clunky satellite phone, no special antenna, just your phone working anywhere on the planet. And when that happens, the possibilities are just mind-blowing. Think about it. Smart sensors on a farm in the middle of nowhere, instantly sending data. Being able to track a cargo ship every step of its journey across the ocean. Giving first responders a vital communication link when a natural disaster wipes out the cell towers. And, of course, finally bringing real high-speed internet to rural homes and plugging all the remaining gaps in our 5G coverage.
Now with this much at stake, you can bet it's kicked off a fierce competition. We're seeing a whole new kind of space race, but this time it's not about planting flags, it's about beaming data.
And you've got some heavy hitters in the ring. I mean, you've probably heard of SpaceX's Starlink. They're already up and running with thousands of satellites. But you've also got giants like Amazon with Project Cooper and another major player, OneWeb. This rivalry is pushing the technology forward at an incredible speed. This isn't science fiction anymore. It's happening right over our heads. And the scale of what they're doing is just hard to wrap your head around. We're talking about companies launching thousands of satellites, creating these massive interconnected webs, constellations, designed to cover every single inch of the globe. And really, it all leads to this one big question. For the very first time, we're on the verge of being able to connect every person and everything on Earth, no matter where they are. So, once we finally close that gap, once everyone is online, what new ideas, what new discoveries will we unlock next? Something to think about.